previous session, we have seen how to construct a system using language template in IC Design Suite. In this session, we'll be constructing an involved maximizer module wherein the problem statement is as shown. So we have 4 numbers of 4-bit numbers as an input to the system, and output will be the maximum of this set. So we can define this either structurally or behaviorally. So in this session, we'll be seeing only the structural way of description. So the basic structure what we'll be preserving is a 4-bit 2:1 multiplexer. So out of these 2 inputs, the maximum will be going ahead to the other multiplexer, and same with the other part. And the transfer will be taking place via a wire, a 4-bit wire. So let's create a new project. Having done that, we'll first create the basic structure of 2:1 mux. So we'll be selecting a Verilog module. So here, inputs will be A, B, and output will have a select line and an output. So we'll declare A, B, a select line, and then the output. So the select line is a single bit, and the inputs A and B are 4 bits. So we'll be writing it as 3 down to 0, and output is again 4-bit number. And the functionality of the module, like 2:1 mux, can be best described by the following statement. Wherein, if select line is asserted, output will be the B. So B is the MSB. So B is the output if the select line is asserted. So let's create the top level module wherein we'll be instantiating the basic 2:1 multiplexer. The terminals for this module will be A, B, C, D, and then the output Q. So all the inputs are 4-bit. And similarly, output is also 4-bit. So apart from this, we need to declare the wires as well, which are also 4-bit. So the declarations are done. So let's quickly instantiate this module. And one of the best way or best practice to instantiate will be to copy the module declaration and then commenting it, and then easily instantiating in the main module as shown. Then here we'll be having A, B, and then the select line will be using a comparator wherein the maximum of A and B amongst A and B will be the output. So here we'll be writing A less than B, because when select line is asserted, B will be the output. So if B is maximum, B will be the output. And then we'll be copying the instantiation and we'll change the module name, and here we'll write CD and similarly the select line declarations, and then the output will be collecting in wires. So instances are created. So the module is ready for the simulation. So one can quickly synthesize and check the register transfer level schematic, wherein one can see the structures of 2:1 marks. So this is what we call as structural description. So here we have the top level block, which looks more or less similar, and inside we have 2:1 marks structure and with 3 comparisons for the select line. So this is what we talk about. So this is what we call as structural description of a module. So to test the functionality of maximizer, we'll create a test fixture. And then we'll be appropriately defining the inputs. Note, all inputs are 4-bit. And to speed up the input declarations, we can define the 4 bits as decimal number. So we can define 4-bit numbers as decimal between 0 and 15. So let's have a few more variants for the input. So according to the description, we require output to be the maximum of the given set at any instant. So let's switch to the simulation mode and then quickly simulate the module. So the output is available in the iSIM program. So let's quickly change the radix to unsigned decimal so that one can read it. One can readily read the output. So let me quickly change the output color so that we can distinguish from the inputs. So out of the set, we have maximum as 3, and here we have maximum as 14. And if all the inputs are same, we have the same output. So here the functionality gets verified.